This section examines the principle of the clutch. A clutch connects and disconnects one rotating mechanical component from another. An automobile clutch transmits torque from the engine to the transmission, and the driver uses a release mechanism to control the flow of the torque between them. Most light vehicles use a single-plate friction-type disc, with two friction facings attached to a central hub, splined to accept the transmission input shaft. The friction facings are clamped between the flat surface of the engine flywheel and a spring-loaded pressure plate bolted to its outer edge. The input shaft passes through the center of the pressure plate to engage the splines of the friction disc hub. With engine rotation, the flywheel and clutch assembly rotate as one unit. Engine torque is transferred from the flywheel through the friction facings to the splined hub and into the transmission. Moving a clutch pedal operates the release mechanism to control the flow of torque between the two units. Depressing the pedal retracts the pressure plate against the force of its springs and frees the friction disc from its clamping action. Releasing the pedal reapplies the clamping force and reconnects the two units. This control is necessary when placing the transmission into gear. The transmission input shaft must be disconnected from the engine. When moving the vehicle from rest, slowly releasing the pedal gives a gradual engagement of the drive as the friction facings slip and allow torque to be applied progressively until both units are rigidly connected. When selecting an alternative ratio, that is, changing gears when the vehicle is in motion, the transmission of engine torque must again be interrupted for this to occur. And when bringing the vehicle to a halt, the transmission must be disengaged to leave the engine running at its idling speed. The amount of torque a clutch can transmit depends on the coefficient of friction between the friction facings and their mating surfaces, the mean radius of the facings, the number of facings in contact, and the total spring force. Increasing the diameter of a clutch increases its torque capacity, as does increasing the spring force. Two or more clutch plates can be used to form a multi-plate clutch, increasing the number of facings and torque capacity. They are useful where a reduction in diameter is advantageous or where increasing the spring strength is undesirable. Most light vehicles use a single-plate clutch to transmit torque from the engine to the transmission input shaft. The flywheel is the clutch driving member. The clutch unit is mounted on the flywheel's machined rear face, so that the unit rotates with the flywheel. The clutch unit consists of a friction-type disc with two friction facings and a central splined hub, a pressure plate assembly consisting of a pressed steel cover, a pressure plate with a machined flat face and a segmented diaphragm spring, and a release bearing and operating fork. The friction disc is sandwiched between the machined surfaces of the flywheel and the pressure plate when the pressure plate is bolted to the outer edge of the flywheel face. The clamping force on the friction facings is provided by the diaphragm spring. Unloaded, it is a dished shape. As the pressure plate cover tightens, it pivots on its fulcrum rings and flattens out to exert a force on the pressure plate and the facings. The transmission input shaft passes through the center of the pressure plate. Its parallel splines engage with the internal splines of the central hub on the friction disc. With engine rotation, torque can now be transmitted from the flywheel through the friction disc to the central hub and to the transmission. When the clutch pedal is depressed, the movement is transferred through the operating mechanism to the operating fork and the release bearing. The release bearing moves forward and pushes the center of the diaphragm spring towards the flywheel. The diaphragm pivots on its fulcrum rings, causing the outer edge to move in the opposite direction and act on the pressure plate retraction clips. The pressure plate disengages and drive is no longer transmitted. Releasing the pedal allows the diaphragm to reapply its clamping force and engage the clutch, and drive is restored. This section examines operating mechanisms. Movement at the pedal pad is transferred through an operating mechanism to the clutch assembly on the rear of the flywheel. This mechanism may be mechanical or hydraulic. Mechanical systems may use a system of levers, but cable operation gives more flexibility and is more common. This is a cable-operated control for a front-wheel drive vehicle. The outer cable is fixed to the pedal box inside the vehicle and to the clutch housing in the engine compartment. The inner cable connects between the upper end of the clutch pedal and an external lever on top of the clutch housing. This lever is connected to a vertical shaft supported in the housing and attached internally to a release fork, which carries the release bearing. Depressing the pedal relays the movement through the cable, and the release bearing thrusts against the diaphragm fingers on the pressure plate. An adjustment on the cable provides for a minimum amount of free play to be maintained between the release bearing and the pressure plate fingers when the pedal is in the released position. This prevents constant contact of the bearing with the fingers and subsequent rotation of the bearing when the engine is running. A large force is required to depress the pressure plate fingers, so the system gives a mechanical advantage of around 8 to 1. This means the force applied at the pedal pad is magnified 8 times at the release bearing. The corresponding movement ratio can give a pedal movement of up to 200 millimeters, while the release bearing only moves a fraction of this amount. In hydraulic clutch control, the pedal acts on a master cylinder, connected by a hydraulic pipe and flexible hose to a slave cylinder, mounted on the clutch housing. The slave cylinder operates the clutch release fork. This vehicle uses a center valve master cylinder. With the pedal in the off position, the center valve is clear of the inlet port and fluid can flow to or from the reservoir into the cylinder. When the pedal is initially depressed, the piston is moved forward, taking the valve assembly with it. The center valve closes off the inlet port from the reservoir, trapping fluid in the cylinder bore. Further piston movement displaces fluid through the outlet port and into the connecting lines to act on the slave cylinder piston. The movement of the slave cylinder piston is transferred through a push rod to the clutch release fork to operate the clutch. When the pedal is released, displaced fluid returns to the master cylinder, and the centre valve returns to being slightly clear of the inlet port. In light vehicle applications, the pressure plate is normally a diaphragm type and is serviced as an assembly. It consists of a pressed steel cover, a pressure plate with a machined flat surface, a number of spring steel drive straps, and the diaphragm spring. This diaphragm is located inside the clutch cover on two fulcrum rings, held by a number of rivets passing through the diaphragm. The pressure plate is connected to the cover by the spring steel drive straps, riveted to the cover at one end and to projecting lugs on the plate at the other. Retraction clips hold the pressure plate in contact with the outer edge of the diaphragm. During clutch operation, they move the plate away from the flywheel. This section examines the driven centre plate, also called a clutch disc or friction disc. The driven plate has a pair of friction facings, usually of wire-reinforced asbestos composition, carried on wavy spring steel segments, which are riveted to a steel disc. The central alloy steel splined hub is separate. Drive is transmitted from the disc to the hub through heavy torsional coil springs or rubber blocks. This spring hub arrangement dampens torsional vibrations from the engine. It also absorbs shock loads imposed on the driveline by sudden or violent clutch engagement. Stops limit the radial movement of the hub against the spring force. A moulded friction washer between the hub and spring retaining plate also acts as a dampener. The waved spring steel segments cause the facings to spread slightly when the clutch is disengaged, then compress as it is engaged. This has a cushioning effect and provides smooth engagement. This section examines the throwout or release bearing. The clutch release bearing can be a thrust-type angular contact ball bearing supported on a carrier. It slides on a hub or sleeve extending from the front of the transmission. The bearing carrier locates on the clutch release fork. Moving the fork brings the bearing thrust face into contact with the pressure plate fingers. This causes the bearing to rotate and absorb the rotary motion of the fingers against the linear motion of the fork. The bearing is packed with lubricant during manufacture and requires no periodic maintenance during its service life.